So I guess the first thing is I'm going to give you some time to get on your AWS machines. I have also posted the workshop materials into the chat so you can follow along. There is one big change. We're not going to do the uploading to GitHub this time around because that didn't work with the AWS machines. It worked last year, so it's a bit unfortunate. So I will do it, but you don't have to do it because I don't think it's going to work for you, unfortunately. Okay, so let me just share my screen. I'm going to share the tutorial first, and I'm also going to run this workshop in order to be able to show you how to do the GitHub dissemination. I'm going to actually do this workshop on my own RStudio rather than on the AWS machines, so on my own computer. But before all of this, I want to talk about what Bioconductor packages are. Well, I hope you have gotten sort of like an overview of what Bioconductor packages are. But if you're just here for this, then a Bioconductor package is simply something that provides tools for the analysis and comprehension of high throughput genomic data. And it is available on the Bioconductor repository. So the Bioconductor site, in case you haven't seen it, looks like this, and it's very slow in loading. So this, it's available here, and every package is indexed like this. Broadly speaking, there are 4 types of packages. There is an annotation package that contains data bytes like packages, for example, any genome references. Experiment data, these are data sets that you can use in order to showcase how your methods work. Software packages, that's sort of the main functionality, which is implementing new visualization methods or algorithms, as well as workflows. Those are like long-term form vignettes that illustrate how to use a particular type of data form or how to do a particular type of analysis. So for the purpose of this workshop, we'll only do looking at software packages. Okay, so why are you going to make a Bioconductor package? Well, it's a really simple way on how to distribute code, R code, and there will be documentation related to the analysis, and it's basically built regularly and made sure that it's actually working really well. And it, you know, it's managed in a way that it can be installed on multiple systems. Doesn't matter whether you have Linux or you're on a Mac or you're on a Windows. And when you make a Bioconductor package, you're actually contributing to open science. And that means that your software is going to be accessible, it's going to be open to everyone to use it, and this will increase reproducibility and reduce the replication of work. So, because anyone can just download your package and go straight to the analysis. But the main, probably the most important thing is that you, as the creator of a new method or a new visualization technique, want to have people using it. So this is an easy way for people to know about your package, get onto it, use it, and then credit you and get you to your next grant, hopefully. Okay, who should be making Bioconductor packages? Well, actually anyone with a little bit of R programming experience can make a Bioconductor package. I'm going to show you that it's actually really, really simple. Hopefully, fingers crossed. And when should I be making a Bioconductor packages? Well, you know, you're probably ready to make a Bioconductor package when you have sort of a set of functions that addresses a sort of problem and that are in a way slightly cohesive, and that you think are useful to other people with the same problem. And if you have this, you can go along. A lot of the times, you know, things like this might have already been done, and don't be discouraged by this. You can probably contact the author of the package that is doing what you sort of want to do and help them in the implementation of this, or help them maintaining their package. And package authors like have a lot to do, and they will be delighted by offers like this. How do I make a Bioconductor package? It's like making an R package. There's just a little bit extra, and we'll talk about this in the workshop, but that will be the main focus of the rest of the workshop. Okay, so there are a couple of things that you need to keep in mind with Bioconductor packages, because they have a little bit of a higher standard than your packages that you'll be downloading from CRAN, for example. And one of the main important sort of principles in the Bioconductor packages is the reuse of implementations that already exist in Bioconductor. So currently there are 1,903 software packages on Bioconductor, and you are really, when you're creating a new package, you're encouraged to use the work that is in those 1,903 software packages. In particular, you should be using things that are created by the Bioconductor core team. And these are packages that are well tested, that are central to the Bioconductor project, and that provide really important infrastructure in order to facilitate analysis, such as genomic data analysis that is really facilitated by the summarized experiment object class. So here's a list of these like really important classes that you should absolutely try to aim and reuse. Obviously, there are sometimes like situations where you want to create new classes, and that's also possible. But for the vast majority of cases, you should be looking towards these. So you have genomic ranges, which is basically data with genomic coordinates. The summarized experiment class that is any experiment with rectangular features, sample data. Our track layer for importing GTF, GDFF, BED, bigwigs, genomic alignments for SAM and BAM files, the variant annotation class for importing VCF files, our SAM tools for SAM-BAM files, again, biostrings for representing DNR, RNA, and AA sequences, especially when importing FASTA files, short-read for working with FASTQ files, MSN base for using mass spec data, GSEA base for working with gene sets, and a single-cell experiment, which is actually an underclass of the summarized experiment class when working with single-cell data. Not only are you meant to reuse things, you're also meant to build your Bioconductor packages in a modular way. And what do I mean by this? Well, modularity means that any packages in Bioconductor are meant to be broken into smaller parts. They're not really meant to be one huge big function which produces sort of everything, but instead you're meant to have, a step-by-step process. So short functions that are easy to comprehend, functions that can be used across multiple problems are definitely something that is favored, and users are meant to be able to check results in intermediate steps. So when I don't want to do the whole sort of single cell workflow in one go, but I instead want to break it down into my normalization step, my loading the data step even before that, and then my batch correction, and so on, and dimensionality reduction. So I want to have all of these separated out. Finally, it's really important for Bioconductor, and they do really insist on that everything is documented incredibly well. And when I mean we're documented, there are actually two things. One is you document your functions so that there is a manual that is created, as well as you want to have a vignette that actually helps a user go through your Bioconductor, so what your Bioconductor package does and how one is meant to use it. All right. Now off to making a Bioconductor package. But let's, I guess, stop. Is everyone on the AWS machine? Anyone can give a thumbs up that they have managed to get there, or put it in the Slack. Yeah, that sounds good. I got one thumbs up, so that's great. So let's assume that you guys are on the AWS machine. I'll now start sharing my RStudio session, and let's get to it. So, okay, I think that's it. So the first thing, so again, no need to worry about anything to do with creating a GitHub account, getting onto GitHub, we will be using Git in order to do version control, but we won't be disseminating onto the online stuff. But don't worry about it if that is confusing at the moment. Hopefully we'll get there. Okay. First of all, you have a couple of packages that will help you with building the Bioconductor package that you're trying to build. And these are here. So we're just going to put them into, these are the following. So it's in the workshop material. So it's the use this package, Roxygen 2, DevTools, good practice, and BioC check. I hope these load for you guys. Okay, so the next thing is that I've already mentioned it, that you want to, if you're making a Bioconductor package, you want to start with version control. And that has got two really main reasons. One of them is that version control is central to disseminating your package. And two, it is just one of the things that you need to do when you want to work reproducibly and you want to make sure that any changes that you're making are tracked. So what is GitHub or Git? First of all, what is Git? Well, Git is basically track changes in Microsoft Word on steroids. It documents everything you do, and so you can get back to any point in stage. So when you make an accidental error, you can just go back in time and you are back to where you started. So there's multiple ways of doing version control. We will use Git in order to do this. Git is a software that facilitates version control. And also helps you work with other people on the same project. And Git-based project can be hosted on cloud-based services such as GitHub, Bitbucket, and GitLab. And again, this is the part that you guys aren't doing. It's just me that is going to be doing this and showing you this. So you can think of this as sort of your Google Drive, where you're pushing anything that you want to share with the world. And it's sort of like a second storage space that is separate from your own computer, which is great. And it also allows you to work with other people. Okay, so version control with GitHub is really easy. And this is basically what you're going to have to do to enable this is to get a GitHub account, install Git on your local machine, and then connect your Git to our studio. And unfortunately, we weren't able to do this under AWS machines, but typically what you would use is the following command in order to, and I'm gonna post this into, because you guys are seeing my RStudio. So typically the way you would connect your GitHub account to your RStudio is by using this use Git Config. Once you have installed Git onto your computer, and there is information in the tutorial on how to do this. And all you need to do is you need to replace this with your GitHub username. So this would be mine. And I've already done this, so there's no need for me to worry. And then this with your email address that you're using for GitHub. Easy as. And then this immediately will connect your RStudio version to GitHub, to your online repository, and everything should be perfect. Fingers crossed. So this would be mine. Again, this is it. And you would just run this through your console down here. I can actually do this, maybe. There you go. And hopefully this would tell you, and it might ask for a password at some stage. Okay. Okay, so let's get started with actually building the package. So the first thing that you want to do is you want to change some things in your RStudio in order to actually have the same layout that Bioconductor prefers. And just think of this as changing sort of the layout in your Word document. It's just that Bioconductor is really particular about how packages should be formatted. So what we're going to do, and I need to, oops. So you're going to navigate to the tools menu, and then you're going to, so within your RStudio, going, you might not be able to see this. Are you guys seeing this? I'm not sure. Let me, right, I'm going to quickly switch my, because I'm not sure you guys will be able to see this. So I'm going to quickly show this.
Saskia,
yeah.
There's a question here. Somebody has a problem.
Yep.
Okay, you saw that.
I didn't see that yet.
Okay, I need a personal, okay, the system complained that I need a personal.
Oh yeah, as I said, again, it's not going to work on the AWS machine. If you try and GitHub, it's not going to work on the AWS machine. As I said, this part, do not do this part. This part is just for you when you're actually doing this on your personal computer. Unfortunately, we weren't able to get this done with the AWS part. Does that make sense?
So they're going to follow, basically listen to you, just listen to you.
Or is this? Yeah. Okay, that seems to have worked. So you will be able to make you will still be able to make the Bioconductor packages, just about the dissemination that you won't be able to follow along with. Where is this? Okay, there we go. So I'm just not sure that you would be able to see this if I change this in my RStudio. But basically what you're going to have to do, you can find this in the tools menu on the global options, and then there is a code panel, and you would change the tab width to 4. Because that's how that Bioconductor likes it. And then you would set the column width marker in the display section to 80. So you are forced to never go like, well, there is some sort of visual border where you can see that you don't want to go over. Okay, right. Let's go back to the RStudio and actually start to make, once this is all done, and in my case, this is done, you would go back to, we're back to RStudio. And the first thing we're going to do is we're going to actually open a new project. And we're not going to do that. Can I? Okay, that took a while to come up. And then you can already see that we have options here. So you can say, let's do version control and say git, right, no, that's cancel. Sorry, sorry, we're going to have to, so sorry, we're going to do a new project. That's where it is. So you clicked on File, New Project, and then in New Project, we're going to actually select an R package. And then we're going to call this R package praise me, because we're going to create a very, very simple package that would not fit Bioconductor's standard guidelines of making things that are for high throughput genomic data analysis, but we're just going to make something really simple so we can focus on the creation of the package rather than the contents. And then we're going to also click create a Git repository. And that's basically it. And we're just going to say create project. And sorry, I'll have to switch over again because my screen share just stopped because it opened a new little window. But now what you should be seeing, and I hope everyone can see this, is a new little RStudio session that has in the files section on the bottom pane actually has already some content. So you have a git ignore file, an .r build ignore, a description file, a manual file, a namespace, a praise me project file, and R. So this is sort of like the main framework of a package that is already pre-built for you here, and you don't have to worry about it. Basically, all we have to do is fill out these things. But first, back to actually explaining what each of these little bits are. So let's first start with the description file. So the description file is the little file that tells us a little bit about your package, and basically it's technically a .dscf file, and it does jobs of detailing a series of fields to tell R about what's in the package and how to use it. And you currently have something that is auto-generated that you will have to fill out. So the first little bit of it is the package, which is just the package name. The second is the type, which just says package, and you don't have to change this. This is just basically a historical little thing that is left over. And then this is the title, where you just basically say what the package does. So the package is the following. So it's just going to be a package that disseminates praise to the user. There is a version number. So version numbers, there are 3 numbers to the version number. The first one, the second one, and the third one. And basically the way that it works is for Bioconductor. Oh, sorry, this is actually not going to be filled out. No, it is filled out correctly. But basically, you have a major release, a minor release, and then like sort of your developmental tracker in the sort of, so in Bioconductor, your Y, so your Y value, so the middle value, the second one, is automatically bumped up with every release, while the minor number is the minor release, which is basically you have to just bump it up every single time that you use it. Just every single time you make a change, just make sure that you bump that up. The other thing to note that is important about the middle value is that in a release number, it's always going to be even, while in the development branch in Bioconductor, we're going to get to what those are in a little bit, it's always going to be odd. Next thing is, so we're going to actually keep it that way. And then we are going to, the next thing we're going to change is you're going to have to, whoops, you're going to have to put your name into it. And then the next one is you wanted to have the maintainer, so the person who keeps the package running and is accountable for any issues that are coming up, and then put your little, your email address here as well. And the last bit is going to be some sort of description of what it does. So this is going to be a simple package that provides praise. This is one I got more we're going to put there. And then there is going to be a license question. So there is basically under what license is distributed, we're going to put MIT. And then we're going to get rid of the lazy load option because Bioconductor doesn't actually like that one. All right, and that's the description done. So we're going to save this. And at that point, you can also, at that point, what we're going to do is we're going to actually do GitHub. So we're going to go to the Git pane, which is on the top little bit. It's the last window there. And we're going to do a commit. So commit is kind of like your save in. So I know we already saved, but with GitHub, we have to sort of save extra. So we're going to save all of these things. I'm just going to click all of them. And then we're going to say these as well. We're going to say commit. And then we're going to say changed or description file, because that's what we did. And then we commit this.
So Saskia,
and hopefully you'll get this message.
So we cannot see your typing, maybe because of the window somehow not in line.
Yeah, this is with R, this is really annoying. I'm so sorry. Yeah, with R this happens, but basically you should be, let me see what I need to just make a change. But hopefully if you look at the tutorial, so if we just go back to the tutorial, what you're going to get a window like this. When you are here in the Git pane, you're going to say accept, And then there will be a new thing popping up, and there you just click commit. And hopefully this will work for everyone. Let me know if this is not going to work. And basically just type in a like short message on the right-hand side that says what you did. In this case, I said change description. Okay, this is the part that only I will do. So you can actually just relax. So the next part is we're going to try to actually push this new package that we're building also onto GitHub. So the way to do this is, I'm actually happy I'm already in the right space. We're going to navigate to GitHub. We're going to navigate to my GitHub, which is not this one. So let me just go to me. And again, none of you have to do this. This is just for me. And we're going to go to repositories, and we're going to create a new repository. We're going to give the repository the same name as our package, so praise me. And then we're going to say that we want to make it public because we want to share this with people. And that will be it. We're going to initialize this. Okay. And then we're going to I will just copy this. And then I will show you how to connect and I will show you how to connect the RStudio, like what the package, your RStudio to your GitHub, so that they start communicating with each other. So the way to do this is by me sharing you the RStudio session. Okay, so we're here in the RStudio session, and you back onto your GitHub pane. So here on the right-hand side, top right-hand side. So you click on this little, so you don't do this, this is just me. Again, you would click on this wonderful little icon here, and then you put in, and I always have to look this up, what you put in there. You're going to click on this, and then you're going to enter master as the branch make, and then, and again, you might not be able to see this, but basically this is all described, master, and this one is none, and then you would say override. Okay, and then we should be connected, hopefully. Why did I do this right? Sorry, this is always a, yeah. Okay. So just make sure that this is correct. Oh, I forgot to add the remote. That's what I did. All right, add remote, and then we have copied. This is what I was doing. This is good. Sorry. So you add origin in the first one, and then you say add remote. You put you say master for the remote name, and then for the remote URL, you would put in the GitHub URL that you have just created. And this should work, but it's not. It's also not letting me do this at the moment, and I don't know why. I'm so sorry. Now there we go. And then you go create, and then this will actually work. So you just have to make sure that everything is lowercase, and sometimes your computer will sort of force you to do this. And unfortunately, you won't be able to see this, but you'll get a message that everything that you're now connected to your GitHub page. And the way that you will see that this has actually worked, you can see that these little arrows here are now, they're actually no longer sort of opaque, but you can actually see them now. And what we can now do is we can push the changes that we have committed now to the online repository. And I'm just going to do this and then show you that this actually worked. Okay, so let's just go back to the praise me package and hope that something has happened here. See, so now whatever all right, sorry, you guys, right, let's see. So here is my praise me GitHub that previously was empty, now has whatever I have on my, in my RStudio is now in the GitHub online. So it's all mirrored, which is wonderful. And you can see that this was done 6 minutes ago and that I have everything here, apart from certain things that are in the git ignore file, which are set not to bother. All right, so far so good. Now let's actually start with writing. We're done with the GitHub pane. We have set up the description of our package, and now we're going to start adding the first function. So stop sharing this. Let's go and actually back to RStudio. And okay, and so like GitHub function, the functions in an R package live in the folder R. And you already have an example function here, which is called hello. And you can see this is a little function, and it will already tell you a couple of things. So we're going to just delete hello. And you can see this change in your GitHub as well. And we're going to make a new file that we're going to save into this folder. And that we're going to call praise me, because that's going to be the name of the function. And it's kind of useful to call your function files by the function name in order to find them again. At least I find this useful. So what is a function? For you guys who might not know what a function is just a little R device that uses a couple of arguments in order to compute something. So for example, a function could be sum plus 1. I'm going to make a function that sums two numbers and then adds a 1. So the structure of the function is always the same. You have you assign a name to the function, and you have this function statement. You're going to put your arguments in there, number 1, and then we have a number 2, and then you are going to have these curly brackets, and in those curly brackets you're going to have the statement that actually of what the function actually does. So in this case, I'm going to have number 1 plus number 2 plus I am going to have plus 1. So I'm going to run this now. So if I do sum plus 1, oops, and have 2 plus 2 in here, if I can be able to type it, then what happens? Sorry, if I have 2 and 2 in there, then it gives me 5, because my first argument is added to my second argument plus an extra 1. So that's how a function works. We don't want to write this function, we want to write a praise me function. So I'm going to give everyone a moment to make a function that makes a praise me statement. The way that this is supposed to work is that the function is called to be praise me. It's going to take a name as the argument, and this name is going to be used in a statement that is praising the person. So I'm going to do the following, and you are free to write something completely different. So this little function now, hopefully, if I use my own name, will hopefully tell me that I am fantastic or awesome. And there you go, it does. So I hope you have all been able to do this. And then at this time, I think it's a good time to talk a little bit more about functions. So a function writing good functions really requires a lot of practice, but the fundamental rules in writing a function is that you want to give functions an evocative name that makes the code easier to understand. Give your arguments evocative names that make them easier to understand for people. Use consistent coding style, really important, and break your functions up into smaller modules that we already talked about, and then comment your code so you actually know what you've been doing. If you want to make sure that you're actually writing the code in the Bioconductor specific style, there's a link in the workshop material that tells you what that actually is, but it has a lot to do with the 4 tabs and not exceeding 80 characters in a line. There's also a package called Styler in R that will automatically restyle your code, as well as another package called lintar that will do an automatic sort of automatic audit of how you have written your code.
Hi.
Okay, so
yep. So there are a couple of questions in the notes. Maybe you want to address that before I move on so that people can follow.
Yeah, sure.
Thank you.
Sorry, it's just sometimes hard to see when there are questions. Okay. Oh yeah, so yeah, thank you, Chris. That that's good. So you don't want to include the lazy data because, and I didn't explain this very well, probably didn't actually know why, because it slows down loading the packages with large data, which sometimes Bioconductor packages have. So thank you for answering that. I think that's it. Can't see anything else.
There's one more question about they missed how you deleted the data, the R file, I think somewhere. Did I miss
Oh,
it?
the R file, it's just, yeah, I'll go back, sorry.
I saw somewhere.
Let me just.
Oh, yeah, I saw it. Did I? Yes, there's one more question. Just show
Yeah,
that.
all right.
Thank you.
I'm just going to show again. So you just click on this and then you click delete up here. I don't want to delete this function at the moment. And then that's how you do it. And then you will see that it's removed up here in your GitHub pane. Okay. What's the last question? I have to stop share every single time. I can't see any more questions, but I might be wrong. Okay.
You answered all.
So we are in a good state here. We can actually move on. Okay, so now you have a function, probably a good time to recommit. So again, for practice, let's just do the commit again, press the 2 files, press commit, write a little commit message on the right-hand side in the pop-up that you're getting that you're not seeing at the moment. Say new function, praise me, for example. It just has to be some sort of message that reminds you what you have done later, so you can go back and then just say commit. And hopefully that will have worked. And then you can come back to your RStudio and have everything saved in a wonderful way. Okay. So the next step, and this is kind of like, this is sort of one of the final steps that we're going to be doing in terms of actually coding, and then we're going to go on to adding a README file, is actually adding documentation. So documentation is one of the most important aspects of a good R package. So without it, users won't actually know how to use your package. And it's also really important for future use, so you remember how you're supposed to use your package. Package documentation in R lives in this folder man. We can actually have a look at it. This is what it would look like. But we do not want to actually change these files. What we want to do is change the praise me file in a way that will automatically create these manual files, and we'll never have to touch them again, because it is really hard to sort of switch between your code and then go to the manual file and keep remembering to update it when they are in two different places, and you're just never going to do it. So the easy way to do it is to use a sort of coding language, which is called Roxygen, which allows you to create documentation within your code. And the way to do it is to say code and say insert Roxygen skeleton. But you have to be inside your function with your cursor. That's really important. Otherwise, it's not going to work. And I wasn't. So again, code and go insert Roxygen skeleton. And hopefully you can see this will change. Okay, so let's talk a little bit about Roxygen. So Roxygen is, again, as I said, it's kind of a coding right documentation. So what this coding language has is that it will have a title, like every Roxygen comment style has to have a title. It has to have, also, sorry, before I actually go on with what those parts is, you will notice this little hash and apostrophe, and this will actually, this actually indicates to R that this is Roxygen code. So Roxygen code always has this in front of it. So that's just really important to remember. All right, so now back to the parts of the actual documentation. So first is a title for your function. So in our case, this would be price me, or a function that does pricing, I guess could also be. And this is how you'd be able to, this is sort of what will come up first in the documentation. The second paragraph is a description of what the function actually does. So wait a second. And the wonderful thing is that I'm just going to say praises user here. This is because it's a bit more evocative as to the thing. And then we can, in the second paragraph, we can say what the function does. So this is just formatting it, this code thing, and it returns a price incorporating a user specified string, because that's what it does. And then the next one here is the add param is describing all the parameters that go into it. So it already filled some of it out for us. It says add param name, because that's what our argument is called. And this is the user specified character, typically a name of a person. Okay, and then you'll have sort of a return field and an export field, which will tell you what the function returns, the value, and this is just a character string in our case. And importantly, also an example of how to use it. So you can say praise me and then, so these are really like all the fields that have to be there. So it's the param field that has to be there in the Bioconductor function, the examples field has to be there, and the return field has to be there, the add returns field. We're not going to worry too much about the add export field at the moment, but that's basically just telling it to export it to the namespace so it's available to the users and it's not an internal function. For those of you who know what that means, that's great. For the other ones, don't worry about it, just basically don't touch it in most cases. Okay, and we're going to save it. And then we're going to I'm going to show you how to generate this documentation and the namespace. So I've kind of talked about the namespace already a little bit, but the namespace, you might have seen it here on the bottom pane, that it's in your files. And the namespace is basically the file that tells on how, in what order to load the functions and how to build the package. Again, Roxygen creates this namespace for you, which is beautiful, because you wouldn't want to do it yourself, trust me. Okay, so in order to, and I have more information again regarding the namespace at least I have links to where you can find more information. Okay, so once you're happy with your documentation, what you can do is you want to process your documentation. So you want to generate this manual file. And the way to do that is to actually first delete the namespace, because we're not going to longer need it. And we're going to regenerate it. And then you're going to have to tell R that you are working with Roxygen. And in order to do that, you're going to, and that you are generating the namespace automatically and all the manual spaces as well. You are going to go to your files. You're going to go to your build pane. So the build pane is, you might have noticed this, is up here. And you're going to go to more, and you're going to say configure build tools. And again, you probably won't be able to see this, but hopefully a thing will pop up and there will be a checkbox which will be able to see generate documentation with Roxygen. And you click this and there will be another thing coming up, and you just say okay. And then that should be it. Then you can hopefully, sorry, this is really massive. And then you can say okay, and then we will be back. Okay. Right, this should be good. So now we are building this. So now in the more thing, you'll be able to say, so in the build pane, again, on the more, you'll be able to say document. And now we're going to be documenting it. And hopefully this will have changed everything. And in the manual spaces, we're going to see a new little function, a new little file that was created that is actually the documentation for that function. That's all wonderful. We're also seeing the old documentation for the hello file that we do no longer need. So we're just going to delete that as well, so that everything is in order. Okay, good time to commit again, because we want to save all the changes that we're making. And it's it's important to keep regularly doing this so that you can, in case anything goes wrong, you can come back in time and use a time machine. Okay, so we're going to navigate to the Git pane. We're going to click everything we have done. And we're going to say commit. And I didn't click everything, so let me just put the manual pages in there as well. And then again, on your right-hand side, say a little commit message, documented function, and say commit, close. You don't have to push every single time. So I could be, again, you can't do this, I could be pushing to my online repository, but you don't have to do this as many times as you commit, because the commits will save what you have done. You can go back to any time and space where you have committed, not where you have pushed. So the push is just sort of additional once you want to actually put it to the online space. Okay. Well, so in essence, we've actually built a package now. We only have one function. You probably want to do more functions. And again, it's the same type of type of going about it. You would write your function, you would document your function, you create documentation namespace using the methods that I've just shown you, and you have a package, and you keep redoing this until your package sort of like looks the way you want it to look. Intermittently, you'll want to check that your package actually builds. So, and the way to do this is that you go into your build pane. And let's hope this works into your build pane again. Go under more and then say build source package. And that worked. And now you have basically built an R package for the first time. All right, that's it basically. This is DevTools built. This is using DevTools built internally, and basically it's creating a tar file that contains all your package contents that would be platform agnostic and transportation friendly, and that's actually what gets uploaded onto Bioconductor. So, and that was what you guys download when you say Bioconductor BioC Manager install, importantly. So next you'll want to see, okay, so I've done this. So next we want to see whether you can actually work with this new package that you have created. So for this, we're going to go to the build pane again, say install more.
Saskia?
Yeah?
We have questions.
We have a question, okay. Oh, I'll get to how to upload to Bioconductor in a second. Thanks for that question. With the remote and the branch name, this is just the way it has to be. And it has to be origin in the branch name and then master in the remote for it to work. And God, I'm not a super GitHub expert, but that's what works for me. So here, remote is the GitHub repro URL, like, yeah. And how to upload to Bioconductor, again, we get to that, but it has something to do with basically having this GitHub repository, because that will allow you to really easily get to Bioconductor. Okay, let's test our package, which is probably the thing that people are most excited about. And we are at that stage where our package is fully built and we can actually play with it.
We have another
okay, back to
we have another
oh, sorry, okay.
About the code.
Oh, the code name of function, what does that do? That formats it really nicely. And we're going to see in a second what it does. But basically it puts in a different font. So it's clear that it is a function name in the documentation. We're going to see that in a second. Okay. Okay, let's go back to my RStudio. Oh, more questions? Okay. Right. Share. Wonderful. And okay, here we are back here. We're going to press in the build pane, press install and restart. And this will build your package and also load your package. There we go. So we have loaded the package. See, library praise me. And now let's do praise me, and let's say a new name instead of constantly saying my name. And that still works. So that's wonderful. And the other thing to test is whether our help pages work. And this is what I was going to say. So help, if we say help praise me, so I want to know what the praise me function actually does. What I will get in the bottom pane is on the helps actually comes up. And here you can see what the code function name has actually done. It has put praise me into this font here. And it tells you how you would use it, what the arguments are, what the value that you get back is, and an example as well. Wonderful. So in order to now, we are at this stage, wonderful, you have, you've got a package now. I'm going to go back to sharing my workshop material. What you would also need to do in order to actually be Bioconductor ready is you would have to write, or you should be writing some, you should be testing your package in order for it to be Bioconductor ready. And the way to do it is that Bioconductor has a has an R package that checks the entirety of your package automatically, and it's within the BIOS. So basically what you do is you just load the BIOS check, which we already have done, and then when you are in, you can just use the BIOS check command and run that, and that will run through everything that you still need to do and tell you whether your package is ready for submission or all the things that you need to swap out. The other thing that you need to do is, if you were, there is, you could also use the library good practices in order to check whether your code adheres to general good practices. With the BIOS check important, sorry, I'll just have to go back. With the BIOS check, it's important to do requirements. It will come in 3 layers. We'll have requirements. The requirements are necessary. You'll have to do these. Recommendations are things that you should be fixing but are not super, super important, and considerations are usually a really, really good idea to do anyway, but again, are not critical. If you were to submit to Bioconductor, the other things you would have to do is you'd have to include a vignette. So that's the thing that we talked about, and there is a way of doing that that is described here. Unit tests that test automatically test functions that you have written are also a nice idea, and you can do that with the test.app package. Again, that's really nice, as well as a news file, which you can amend every single time you update your package to say that. And then wonderfully, with GitHub, you can also set up GitHub Actions, which allow you to check your package every single time you commit it and push it. However, they are a bit tricky to set up, but you can, in the BIOS dis package, which I strongly recommend to you, you can really easily set them up with use BIOS GitHub Actions. Okay, so once you've done everything, you've pushed everything importantly to GitHub, it runs, it is passing BIOS check, you're ready to disseminate. So the way to, so this is, I'm just going to skip this section. Would be adding a README file that would, and I might do this in a second, but I want to talk about, again, the Bioconductor submission process first. So in the Bioconductor submission process, it works through GitHub, and that's why I've set you up with GitHub here. So this is why we did the whole version control pane, because when you pass this first hurdle, you're on GitHub, everything is really, really simple. Basically, once you're ready, it passes, as I said, passes all the requirements. You can basically open a new issue in the Bioconductor contributions repository, and have given you the link here, and follow all the guidelines in the README file, and you're good to go. And it's just really simple. You basically just link your GitHub repository that you want to be considered as a Bioconductor package. After you've done this, what happens is that there will be a review of your package. So you're going to get a package. The package will be labeled as awaiting moderation, and the very friendly Bioconductor team will then take a brief look at your package and ensure that it is intended for Bioconductor. If it's appropriate, it will be reviewed. And basically it will be submitted to the Bioconductor build system, where it's built, every package is built like nightly or second nightly. And then an actual person will go in and try your package, read your vignettes, and see whether it works for them or not. And they will give you a review back, and then you basically have to respond to the primary reviewer, and you're encouraged to address their concerns and modify your code in a way that will fit what they have suggested. And when you have addressed all the concerns, you can just basically resubmit by increasing the minor release, importantly, and that will trigger a new build on the Bioconductor system. And then the reviewer will reassess, and they will either accept your package for inclusion in Bioconductor or decline it. And that's it. And they're really friendly, and there is really no way to be scared about this. This is not like a paper review. This is a friendly review with really good suggestions that can be done in a timely manner. Important to know is that Bioconductor works on a release cycle. So there are 2 submission dates per year that you're working towards. One is typically in April, one is typically in October. When you are working in developing your package, you should be working on the devel Bioconductor version. So that's where all the new packages are and what will be changed, and not on the release cycle. That's really important. So it will, once it has been accepted, your package will be initially living on the devel branch, and then when it goes into release, it will be living on the release branch. That's how it goes. If you have any bug fixes that are like really major, they can be introduced to both the release and the devel branch, but like new modifications of your package should only ever be pushed towards the devel branch. Okay, so I want to talk quickly about what I wish I had known before I started. I wish I had known that dependencies can be really annoying. So, you know, make sure that you don't just include every package in your, depend on every package in your, but actually sort of pick them well. Because, you know, if they change something, their changes might break your package, and then you'll have to change things again around. Be mindful of package size. Bioconductor software packages are limited to 5 megabytes, so don't include big data sets, but instead, if you need a big data set, then you want this to be pushed, you want them to live somewhere else. It is also necessary, like if you have other things, is sort of like other files that you only are using in the initial stages of development, remember to never push them to GitHub, to your GitHub repository, because otherwise you're going to live in a whole lot of pain later on. So put them into your git ignore file. Finally, a lot of the object classes in Bioconductor are S4 classes, and they might, you know, if they might sound a bit more complicated than the widely used S3 classes that we commonly see on CRAN. But in reality, this preference for S4 classes will only impact you if you are really set on implementing new methods. Otherwise, if you're just using old, you know, objects that are already implemented in Bioconductor, you're going to be good. Right, now for where you can get help. So there are many excellent tutorials and books about writing R packages. These are my favorite ones here. There is also stuff that is specific to creating Bioconductor pages, and you can like follow these guidelines. But what is probably most important is the amazing BioC package, which I'm hoping that people will use, because it really, you know, guides you through this, kind of like this tutorial, but in a nicer way. So check that out. And then maybe most importantly, if things fail that you're doing, you know, a lot of the time it's just stepping away from the problem, having a break, drinking a coffee, going on a walk, and then coming back, and you know, the world will look different. Okay, I think that's it. All right.
Now, there are questions you want to address?
So Jeremy has the question of, well, how would he know whether the praise.me is built from the package and not from the global environment? Well, that's a good question. You can actually just delete your global environment and then load the package and see whether it still works. And what happens if my function in my development package needs to use functions from another package? Yes, that totally works, and that will be dealt with in the namespace. So basically, in your description of your package, what you can have is, and I didn't, because of time, I didn't go into this very much, is that you can specify other packages that you want your package to import that you depend on. And there is an import and a suggest file. So there's depends for hard dependency, where you absolutely, where two things are required to work alongside each other. So those are packages that get completely imported in, and then suggests is out of things that are also important, typically things that you use. And then in your Bioconductor, you also have a BioC views file that is unique to the Bioconductor. Yeah, all right. Oh, so yeah, there are so many license choices. It's hard to say. There is a package that, and I think I might have mentioned this in the workshop material, that tries to help you with this package. But for most people, probably MIT would be or an artistic license too would be something that is appropriate. But again, that depends what you're doing and what your university or your employer says about these things.
Okay, thank you very much. We're running out of time. Any other questions? Or maybe take a last one, if anything.
Oh yeah, there's another question about a package name. What if they have already been taken? Well, that's unfortunate, but my advice is to just, you know, come up with something else that's easily Googleable. And that isn't already something, it's just hard. Yes, with 1,903 packages, you can imagine that this is becoming a bit of an issue.